Ask My Instructor 2.3.44. Find this limit for f of x equals 7 over x. Instead of f of x, I'm going to put 7 over x into the limit. Also, look at f of 2. F of 2, that would be 7 over 2. And so I'm going to substitute 7 over 2 in. And so this is the limit that we're looking for. Notice that if we were to plug x equals 2 into this complex expression, we would get 0 in both the numerator and denominator. For that reason, we're going to simplify the complex rational expression in order to analyze the limit or determine that it does not exist. Just to remind you, the problem is if we were to put 2 in at this point, I'd have 0 over 0, which is called an indeterminate form. Indeterminate form means you don't know what's happening. All right, let's look at the numerator. I need a common denominator. The best common denominator would be 2x. So I multiply 7 over x, I multiply it by 2 over 2, and 7 over 2, I multiply it by x over x. So now they both have that common denominator of 2x. And 7 times 2 is 14. 7 times x is just 7x. But I am ready to subtract since they both now have the same denominator of 2x. When I subtract, I get 14 minus 7x all over 2x. This is pretty much as ugly as it was before, but believe it or not, we're making progress. To divide by x minus 2, keep in mind that another way of viewing that is multiplying by 1 over x. So I rewrite it this way. All right, now we're going to multiply, but whoa, hold the phone. Maybe we don't want to multiply just yet. Let's factor the 7 out of these two terms. If I factor out a 7, I'll have 7 times 2 minus x. All right, so I have 2 minus x in the numerator and x minus 2 in the denominator. They don't seem to be the same factor, but let's think about it a little bit more. X minus 2 and 2 minus x, well, one is just the negative of the other. So 2 minus x is the negative of x minus 2. So let's rewrite that as the negative of x minus 2. So instead of 2 minus x, I'm going to put in negative 1 times x minus 2. And there we go. Great. Once I do this, I've got x minus 2 in the numerator and x minus 2 in the denominator. And that allows me to cancel. When I cancel, I end up with 1 over 1. Well, that's just 1. And the cleanup now is going to be fairly easy. All right, so, wow, that really cleaned up nicely. We now have a rational expression where the target point x equals 2 does not result in 0 in the denominator. If I don't have 0 in the denominator with a rational a rational function, which is a polynomial over a polynomial, and if you don't end up with 0 in the denominator, then you can just do a plug-in. So to evaluate, we just plug in x equals 2 into this expression. So what are you going to do when you plug in x equals 2? well, you're going to get negative 7 over 4, and that is your answer. Let me know if you have any questions. Have a great day.